There are many different applications for exponential functions. So remember, you have y equals ab to the x, where a is the initial amount. So I'm going to write the initial amount or the y-intercept. So I'll write initial amount, and b is the growth / decay factor. And it's a growth factor if b is greater than 1, and it's a decay factor if b is between 0 and 1. So to figure out the growth factor, if a population doubles, the growth factor is going to be 2. Now, it gets more difficult when you're talking about percents. So if something is increasing by 13% more, it means if you had 100% of your salary and it increased by 13%, then it would go up to 113%. So what I do is I base everything around 1. So if it's increasing by 13%, I do 1 plus 0.13. Now, because if you multiply a number by 1, it doesn't change the number. So the growth factor is going to be 1 plus 0.13. So I put that together to be 1.13. That's the growth factor. If it depreciates means it goes down. So again, I'm going to start with 1, but I'm going to go down by 4%. So change 4% to a decimal, which is 0.04. So 1 minus 0.04 is 0.96, which is a decay situation, which makes sense because decay is if the growth factor is between 0 and 1, and you got an answer that was between 0 and 1. And then a house appreciates, so appreciates means it goes up. So if it appreciates by 2.5%, it's going to be 1 plus, change 2.5% to a decimal, so it's 0.025. So then you have 1.025. Okay, some examples. Write and solve an equation to answer the following questions. A car is worth $15,000 and depreciates by 11.3%. How much is it worth in 15 years? So your initial amount is 15,000. Your growth factor. Okay, we have to figure out our growth factor just like we did up previously. So if it depreciates by 11.3%, the growth factor is going to be 1 minus 0.113. So you do 1 minus 0.113. 1 minus 0.113 is 0.887. So your growth factor is 0.887. And then if it's depreciating each year and there's 15 years, then x is going to be 15. So I'm going to plug this into y equals ab to the x. So it's y equals 15,000 times 0.887 to the 15th power. And I do that in my calculator. So I get $2,482.82. So make sure if it's money, you round it to 2 decimal places. Okay, number 2. An animal population is tripling every year. Currently, the population is 150. What will it be in 6 years? So the initial population is 150, and it's tripling. So the growth factor is going to be 3 in 6 years from now. So I do y equals ab to the x. So y equals my initial amount, which is 150. My growth factor is 3, and then it's going to be 6 years. So on my calculator, I do 3 to the 6th power, and then times it by 150. And I get 10,9,350. And then the third one, A town has a population of 43,000 people. So 43,000 and is increasing at a rate of 5.4%. So the growth factor is going to be 1.054. How many people will be there in 10 years? So it's y equals ab to the x, so it's 43,000 times my growth factor, which is 1.54 to the 10th power. So I get, not talking about money here, so I'm going to round to nearest whole person. So it's 72757 people. Or depending on how you interpret it, you could say, because the decimal was 56.96, you could say that that's not yet a person yet, so you could round down to. Another application of exponential growth and decay is compound interest. So compound interest means that if you have, it's interest on interest. So if you have $100 one year and you make 10% on your investment, so the next year you're going to have $110. Then if you make 10% on that investment, you take 10% of $110 and you get $11. So then if you add $11, see, I'm no longer adding $10, I'm adding $11, it would be $121. And then if I take 10% of that number, it's 12.1. So now I'm adding 121 plus 12.1. So see how my interest keeps growing and growing, so I get 133.1. Otherwise, if you're just adding $10 a year, 10% of your original amount, this would be 130. So compound interest is interest on interest. So to solve answers involving compound interest, we do this formula. So the P stands for the initial amount. The N stands for the number of times your investment compounds. So if it's quarterly, it's going to compound 4 times a year. If it's monthly, N is going to be 12. If it's daily, it's going to be 365. And then T is the number of years, and R is your percent. And A is rate. A is the amount of money that you have after those conditions. So an investment compounds quarterly at an interest rate of 5.5%. Currently there is $1,000 in the account. How much money will there be in 15 years? So your principal is your initial amount, your P value, so that is 1,000. Your rate is 5.5%, so that's 0.055. N stands for the number of times it compounds. So if it compounds quarterly, it's 4. And T is the number of years, so that's 15. So you use order of operations, and you plug in this expression very carefully using order of operations. So using order of operations, what I'm going to do is I'm actually going to put NT in parentheses, because that is the biggest mistake that people make, is they forget that the exponent is 4 times 15. So what I see people do is they forget, they put this in their calculator like this, caret, and don't use parentheses. So they just do caret 4 times, because that caret represents exponent, 4 times 15. And they take and what your calculator is going to do is take the value of whatever expression is before here to the 4th power, and then multiply that whole thing by 15. But you actually want it to take it to the 60th power. So order of operations, you want to do this part first, inside the parentheses. Then you're going to add 1. Then you're going to take it to the 60th power, and then you're going to multiply it by 1,000. So when I put it in my calculator, make sure you're rounding properly and writing in money form to 2 decimals, 2269.09. So if you try that and you don't get that, double check that you are doing 0.055 divided by 4, adding 1, taking that to the 60th power, and then multiplying it by 1,000. Okay, let's try another one down here. So an investment compounds monthly and an interest rate of 6%, and there's 15,000 in the account. How much will there be in 8 years? So 8, then N represents the number of times it compounds in a year, which is 12. The rate is 0.6 or 6%, so the rate R is going to be 0.06, and your principal is going to be 15,000. Also, you can kind of think about your answers. If you're starting out with 15,000, and the interest rate 6% in 8 years, it's not going to be $1 million. It's not going to be less than 15,000. So just make sure that your answer makes sense. So it's going to be 15,000 times 1 plus 0.06 divided by 12, taken to the 12 times 8 power. So again, I'm going to do this first, which is 0.06 divided by 12, add 1, take that to the 96th power, because this is 96, and multiply it by 15,000. So I get $24,212.14 when I round. And then the last one, an investment compounds semi-annually. Okay, semi-annually means twice a year. The rate is 2.3%, so move the decimal over 0.023. The time is 10 years, and it's worth $12,400. So I do 12,400 times 1 plus 0.023 divided by 2 to the nt power, so to the 20th power. So then I'm going to get $15,586.17.